Hi there S4, and today we're going to be talking about energy. That's what this week's task is on, and we're going to be looking at two equations. But let's first of all look at the first equation, which is work done. And work done is EW equals FD. Okay? EW equals FD. Now, EW stands for work done, F stands for force, and D stands for distance. Now, you will recognise F and D. However, work done is quite an unusual term. But what do we mean by it? I'll give you an example. If my car was to break down and I needed a tow truck, if that tow truck was to pull with some sort of force over some sort of distance, it would be creating work, or it would be creating an energy. Alright? So if that tow truck pulled with some sort of force over a distance, it would create some sort of work, or work done. And that is an energy. Alright? Now, energy is measured in joules, force is measured in newtons, and distance is measured in meters. So let's just make sure we get all that. So work done, and that's in joules in the capital J. Force is newtons, and D is distance, and that's in meters. Right, I'm going to go over to a quick video where I'm with Nova again, and we're going to explain work done and hopefully give you a little bit more of an understanding.
Hi S4, it's Mr. Bull here, and I'm just walking Nova in Lynn Park, and I want to talk to you today about work done, which is EW equals FD. So I've already explained a little bit about it, but remember, it's force times distance gives you energy. Right? Energy is measured in joules. Now I'm going to show you a wee clip of me walking Nova where she's the force and she's pulling me over some sort of distance. So that creates the energy. Alright, so I'm going to show you this in just 2 seconds.
Okay, S4, hopefully Nova and I have explained work done to you there and you understand it. But let's now move on to potential energy. And EP equals mgh. That's the equation. Now, EP is potential energy, m is mass, g is gravity of the planet, and h is height. Now, what does potential energy mean? That is simply just the energy something has relative to its height. So something that is up high, if you let it go, would have a lot of energy, because what does it do? It just falls straight down. So there's a lot of energy that something has if it's really high up. Now, an example would be if I was to have a 5 kilogram mass on the floor and a 5 kilogram mass on a table, the 5 kilogram mass on the floor is not going to have any energy because its height is 0. Whereas, even though it's not moving on the table, the 5 kilogram mass has potential energy. Because if I was to remove that table, what would happen to the 5 kilogram mass? Yeah, it would fall. So it has that energy ready to go if something was just to disappear. So everything has a potential energy if it has a height on some sort of planet that has a gravity of g. Okay, so let's write this in. Potential energy is measured in joules again, and m is mass, and that's kilograms. You'll be aware of that from previous bits of physics. G is gravity, and that's newtons per kilogram. And we have h, which is height, and that's measured in meters. Right. Nova and I are going to explain all this a little bit more, and hopefully, once we've done that and we then do some examples, you'll understand both work done and potential energy.
Hi, S4, it's Mr. Bill, and we're going to talk a little bit about EP equals mgh. And I'm at a height here. We've got the gravity of the Earth, and we've got this mass of a stone. Now, the higher the height I am, the greater the energy will be. So I'm going to show what it's like at this height here with this stone. Here we go. Right guys, so I've done it from the high height. Let's see what it's like when I drop this boulder at a lower height. You'll hopefully expect that smaller height here, it will be less of an energy. Here we go.
Right, now that we've done both equations, let's do two examples, one with work done and the second one with potential energy. Right, for work done, the question says, a boy finds he has to exert a force of 50 newtons to lift a box 2 meters onto a shelf. What is the work done? So we know that EW equals FD. Now, if you wanted to know the triangle, it's just EW at the top, and you have F, and you have D. And we're trying to find the work done, so it's going to be F times D. So, the force here was 50 newtons. The distance was 2 meters. So the work done is just going to be 100 joules. Okay? So hopefully that's a little bit straightforward and you understand that. That's example 1. Okay, example 2 includes potential energy. So example 2 says a woman lifts a 10 kilogram mass to a height of 2 meters. How much potential energy has the mass gained? So we know it's going to be EP equals mgh. If we were to do a triangle for this, it's the same, but EP is at the top, you have 3 at the bottom, mgh. Now we know that we're finding EP, so EP equals mgh, which we have here. We know that it's a 10 kilogram mass. Gravity of Earth is 9.8 and h is still 2 meters. So if we were to do that in a calculator or in our heads, then we would get 196 joules. Okay, which should be our answer for I. There we go. We can't do number 2 in this example because we've not covered the right material, but we will be doing that in the next couple of weeks. So for now, that's just done example 1 and example 2, and I hope that gives you enough information for you to understand both work done and potential energy. Now, the questions will be set for Thursday. Give them your best shot, making sure you have all the working, and if the triangles help, use them. So, S4, well done. Keep up the good work, and we'll see you next week. Bye.